Okay, so on this quiz, you're supposed to find all numbered angles, and I had quite a wild range of scores. So there were some 10s and then there were 1s. So and again, if you're not able to do something, you should really ask before the quiz goes out, because then it's too late. So let's see, where did I start? All right, now I see where I started. So I started right here. I looked at 32 and 38, and I saw that I could find this angle 110, 180 minus 32 minus 38. That and angle 1 are a linear pair, so those two have to add up to 180. So if that's 110, angle 1 has to be 70. These are vertical, so number 2 is also 110. Angle 1 is vertical with this angle in here, so that is 70. 180 minus 70 minus 64 is 46. So angle 3 is 46. Angle 4. If you look right through these three, from this line, you go through those three angles and you return to the same line. So that means they have to add up to 180 degrees. So if that's 32 and that's 46, the piece missing is 102. So you take 180 minus 46 minus 32, and you'll get 102 for angle 4. Again, taking from 180, take 41 away, and you're left with 37. That's all 5 angles for that. And then the second one, let's see, starting with the same idea, angle 1. I leave this line and I go through that angle, that angle, that angle, and return to the same line. So that's 180 degrees. A straight line is 180 degrees. 180 minus 47 minus 69 is 64. 64 and 63 from 180 will give you 53. And 100, let's see, angle, this, a lot of people miss this one. Angle 3 is formed by this line and by this line. So angle 3 is vertical to this angle right here, which is both 69 and 47. So if you add those two up, you get 116, and that's what angle 3 is. Take that from 180, take 20 away, you're left with 44 for angle 4. Here's 136. 180 minus 136 leaves you with 44 for angle 6. And take from 180, take 44 from 180, then take 47, and you're left with 89 for angle 7. And that's those. And we've moved on since then, so if you still have trouble with those, get a hold of me or post it on the message board or something so we can get you straightened out. Okay, so for 14, we are given some things. We are given that AE is the same as FC. AE, FC. We are given that AB, is the same as BC. AB, BC. We're also given BE and BF. BE and BF. So what we're supposed to come up with, we're supposed to prove that AFB is the same triangle as CEB. Same size, same shape. Okay, so let's take a look at this. AFB is that triangle. And then CEB is this triangle. Okay. And that's all we have to go on. And I believe we took 5 minutes to do it, and we came back and we said, okay, the general game plan is to go side, side, side. Because in order to say side, 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 you have to say that 3 sides are equal. You have to say that AF and CE are the same, and we have to work on that one. You have to say that FB and EB are the same, and we got that. And you have to say that BA and BC are the same, and we've got that. So we have 2 out of 3 pieces for side, side, side. And these are all given. So if we could say, this is kind of backwards reasoning off to the side, if I could say that AF and CE were the same, that would be my third side, and we'd be done. Because here's one side that's equal, here's 2 sides that's equal. One more and you can say side, side, side. Well, AF is here, and CE is this one here, and they look the same to me. Now, if you look, they share EF, and you have equal sides added, equal pieces added onto each side of EF. So think about it. If me and Fry Guy each have $10, and you both give us the same amount of money to add to that, then we end up with the same amount of money, right? If we both have $10 and Katie gives us each 5, we have 15. So if we both have the same piece here, and you add equal pieces to each triangle, well, each triangle is going to have the same side. We just have to find a way to say that geometrically, not just common language-wise. They are, but we haven't got there quite yet. All right, well, what is AF? AF is actually AE plus EF. And CE, what is the CE? Well, this CE is actually EF plus FC. FC and AE are the same. It was given that they're the same. So we can do a little substitution and we'll be done. So I'm going to go back here and I'm going to do my real steps. AF is AE plus EF. And FC is, CE is EF plus FC. That is where segment addition comes in. Well, AE and FC are equal. It doesn't matter whether I call this AE or if I call it FC. So what I'm going to do is I'm going to change it and I'm going to call it FC. Okay? And I'm not really going to do that in the proof. That's just to show you. So what I'm going to do is I'm going to rewrite this AF, and instead of AE, I'm going to call it FC plus EF, and that's a substitution. The whole purpose of that is to take these two and show that you want CE and AF to be the same. So we said, well, CE equals this thing. Oh yeah, well, so does AF. They both equal the same thing. That must mean that they are equal. And that's another substitution. You could call that transitive. So there's one side, there's 2 sides, there's our 3 sides. We can say AFB is the same as CEB because of side, side, side. And 16 was a C, it was a D, G, and E. 16, we have some stuff. We have triangle CDE is isosceles. And it also tells us that G is midpoint of CE. And that's it. And somehow, with that information, we're supposed to be able to say that CDG is congruent to EDG. Okay, we should mark some stuff on the drawing. If isosceles, what is isosceles? Is a triangle that has 2 congruent sides. So I can mark my 2 congruent sides. And I should say that. I should say CD is the same as DE because that's what an isosceles triangle is. It means the 2 sides are equal. Well, that's a side of each triangle. What else do we have? Well, don't both these triangles share DG? So DG is the same for both triangles. So what I'm going to do is I'm going to say DG is equal to itself because it's equal. It's the same side in CDG as it is in EDG. And that's reflexive. Remember that one from algebra. I don't know why there's an S at the end of there. DG is equal, that's two sides. If I have one more side, this is over. I need to be able to say that CG is equal to GE. And I can, because it says that G is the midpoint. Well, midpoint means it cuts it in half. So if it cuts this in half, that piece is the same as that piece. So CG is the same as GE because definition of midpoint. 1, 2, 3 sides. I'm done. All I have to do is finish my congruency statement and say side, side, side.